I'm thinking that this video will go much quicker than the last one, but we will see. So we're using increments of negative 0.1 to approximate the value of the function at x equals 1.7. So we want to know what y of 1.7 is equal to, or we're approximating the value of the function at x equals 1.7, where we know again the derivative at any point is 2 minus x. So we have the current value, current x and y coordinates are 2, 1. Okay. And the slope again depends on x, so the slope is 2 minus 2. So just the way number 41 started out. So if 2 minus 2 is 0, then we have y equals 1 as our current equation. Okay, because its slope is 0, y value is 1, so y equals 1. So the new xy is, we have x, which is 2, minus 0.1, comma 1, and 2 minus 0.1 is 1.9. Okay, so we have the coordinates 1.9, comma 1. Okay, that's where we currently are at. Okay, that's where we are currently at. And so we have 1.9, and eventually we'll be at 1.7. So we have 1.9, comma 1. And so again, our slope depends on x. So 2 minus 1.9. 2 minus 1.9 is 0.1. That's our current slope. Our current y value is 1. Oops, didn't mean to do that. Current y value is 1. The slope is currently 0.1. And the current x value is 1.9. Okay. So our y then, at where are we at? 1.8. So y equals 0.1 times x minus 1.9. Okay, and then plus 1. Alright, so then our current y at our new x, so we're going to drop 0.1, so we have 1.9 minus 0.1, which is 1.8. So we're going to go from we're going to go from 2 to 1.9 to 1.8 and finally to 1.7. So y at 1.8 is approximately equal to, okay, 0.1 times 1.8 minus 1.9, which is negative 0.1. Negative 0.1. And then again we have that plus 1. So we have negative, so 1 times 1 is 1. It's going to be negative, and we're going to have a decimal followed by 2 digits. Okay, and then we have, so you want to be on the safe side. Let's just say you're not using your calculator, and you have, this is not something that you necessarily want to try to do in your head. We have 1.0 minus 0.01. Okay, so you go back to the basics, and you get 10 minus 1 is 9, and 9 minus 0 is 9. So you have a current y value of 0.99. Okay, so I know that's pretty elementary, but I've seen mistakes made just on that. Okay, so you just have to be really careful. So that's those are our new coordinates, right? 1.8, 1.8 comma, let me get a better decimal. Decimals aren't really easy to write here. 1.8 comma 0.99. That currently is where we're at, and we just need to do one more linear approximation, and let's put in our 1.8. Let's see here, 1.8 comma 0.99. Okay, well again our slope depends on x. 2 minus 1.8. 2 minus 1.8 is 0.2. So that's our current slope, and our y, I'm going to do this all at once, is 0.2 times x minus 1.8, our current x, plus our current y, which is 0.99. 0.99. Okay. Well then, y at 1.7 then would be approximately equal to, okay, what is it? 0.2 times 1.7. So that change in x, so we have 0.2 times, that in what we're multiplying here, this guy, x minus the current x value, is always going to be negative 0.1. Okay, it's always going to be our change in x, so negative 0.1. It's always going to be our change in x there. And then again we have our plus 0.99. So be careful here. 2 times 1 is 2. The number is going to be negative, and then you have to have 2 digits following the decimal. So we have negative 0.02 plus 0.99. Okay, I don't really like to write it like that because I know I need to take the difference. So I'm not going to try it like that. I'm going to do this. I'm going to write 0.99 minus 0.02, and we get 0.97. So that's easier. And guys, 0.97 is your the approximation for the value of the function when x is equal to 1.7. So that, guys, right there is your answer. And that's it. So that took half the time as the first example, because hopefully now you understand the process. And I don't see any reason why you guys can't do that as far as if you want to come up with, let's say, an argument that, oh, I just want to memorize the formula. I urge you to not try to just memorize the formula without understanding the meaning, because when you try to memorize the formula, then when it comes time to take the AP exam in May, you're going to have to try to relearn this whole thing, when if you just understand that the Euler's method, or that Euler's method is just a linear approximation for finding the solution, or approximating the solution to a differential equation given an initial condition. So that's the whole thing. Euler's method. Alright, you can fill in the details. So we'll see you in class. Finish up problems 46 through 48, and that is it.